Okay, so this is question 7 of our shadow mock paper. It says, let I equal the integral from 4k to 0 of this, and j equal this similar thing, but with a squared there. So the first thing it says is show that I is independent of k. So independent of k is going to mean sort of that the k doesn't matter. So it might sort of disappear, or perhaps there might be some thinking connected here that we need to do. Let's integrate first. It's an integral. Let's integrate and let's take things from there. So let's take a look at this and see if we can find some clues. Now, if k is a constant, a question would say if k is a constant, it would mean what? It would mean that this is kind of just a number, and the x squared would be the main thing that I would look at. And then I'm going to spot that the x squared is connected to this one here. So something based on the natural log of the denominator is going to be the secret. Now, how do I know that? When you do natural log of something, so if you do like natural log of something, when you differentiate, that gives you a 1 over that something. So the denominator will sort of take care of itself. What about the x part? Well, the x part, so that's sort of the outside we've talked about. The x part is going to have something to do with the fact that, do you notice that x squared, so if you imagine u equals x squared plus k, can you see that du dx is 2x if k is a constant, and that is like the same power of this one here, so it's going to have something to do with that. So we're going to go and just sort of do everything formally now, but let's work through that case. So I'm going to say let u equal x squared plus k squared, du over dx equals 2x, and let's sub those results in straight away. So I would then get from 4k to 0, I would be looking at at the moment it's x over the u would be the bit I've just substituted in there, okay? And dx, if we sub dx out, 1 over 2x du would be equal to the dx. And if we put that substitution in there, so instead of dx now, we would get 1 over 2x du. And can you see that that cancels? So that's how you sort of, you can see that that bit that I was doing in my head really by inspection, spotting that these things were connected. Anything else we would need to do? Yeah, the limits need changing, don't they? Because at the moment they're in terms of x, so they should be in terms of u. So 4k all squared would be 16k squared plus another k squared, so that's going to be 17k squared. And the 0 would just end up being a k squared. So all in all, we would have 17k squared to k squared. I'm going to put the half on the outside, and then it becomes, I believe it's just 1 over u du. Let's just look at that. Yeah. Okay. And if we, let's do it underneath. And if we actually now integrate that, so we would have a half from the natural log of u. We've changed the limits, so I suppose we just keep it like that, of 17k squared minus k squared. So what's going to happen next? Let's just put the half there, a big bracket to sort everything out in a minute. So let's change up the colour a little bit. So k squared already a positive, so notice that this modular sign sort of just disappears. So 17k squared minus the natural log of k squared. And when we subtract logs of the same base, what happens with that there? Well, that's actually the same as the natural log of 17k squared over k squared. And this is the moment at which we can say that sort of the k, doesn't matter what the k is, okay? In this situation, you end up with what? You end up with your final answer just of a half the natural log is that of 17. Okay, so interesting question. So when it says that it's independent, it just sort of means that it doesn't matter. Well, you can see that it doesn't matter if it's not in the final answer. That would be a good justification for it not mattering. Okay, so the next one over here says, show that, so this is about this other integral here, is this, and hence it's inversely proportional to k squared. So inverse proportion means when you have, so if I use y and x, for example, it would mean that you had a situation like this. So y, the k is an unfortunate choice, but this would mean y is inversely proportional to x squared, or you could have y is inversely proportional to x, or y is inversely proportional to the cube root of x. So the fact that sort of k squared is in the denominator there tells you, you know, if we get to this, that sort of is proving that. Okay, so we're going to just have a go at doing the integral and show that it becomes this value here. So it looks quite similar, but it's not the same, is it? So the limits are slightly different. There's a squared sign there. Okay, so how are we going to handle this one? Well, I noticed that connection's still there, and I noticed that this denominator is really quite hard for me to work with. So I think I still want u to be the same thing, x squared plus k squared. Yeah, or, you know, it's the same thing, isn't it? Just swapping the order. So that would mean what? That would mean that du dx was also 2x again. Shall we do the limits while we're here as well? So a nice trick, just looking for some clues here. A nice trick that you can do with the limits in terms of how you lay it out is, I quite like to do this here to just check I've changed them. So it used to be k and 0 before, and if we feed them through the rule, it will be k squared plus another k squared, so it should be 2k squared, and the other one was k squared again. Okay, so it's just a nice way, I think, of doing it. So the integral is going to be what then? The integral is going to be, well, it's from 2k squared to k squared. Might as well do that. When things are difficult, just change one thing at a time. So I might suggest here you kind of write this as u squared and then x dx until you've got a handle of what to do. The dx, we changed this one before, didn't we? So what did we say? We said that 1 over 2x du equals 2x. So I think that's going to sort of tackle itself again, isn't it? So that gives me from 2k squared to k squared. We'll write it out the long way. So u squared dx was 1 over 2x du. And I feel like this is deja vu. I feel like the question is very, very similar. So I'm going to end up with, it looks like just a u squared this time. What did I have last time? I had just a 1 over u, so that was a natural log. This one then, what's all this going to turn into? Well, if I clean up the question a little bit, it's half, and then it's 1 over u squared, isn't it? So it's actually a u to the minus 2. So this is not a natural log situation. So sometimes rewriting it in this format here just stops you from accidentally making a mistake with it. So I think we're ready to integrate straight away, aren't we? So let's call this a half. And this is going to be a minus u to the minus 1. Let's just test that works. That looks good. And did we do our limits? I think we did, didn't we? So 1/2 of, let's do all of it in here. So minus u to the minus 1. I'm going to write minus 1 over 2k squared. Yeah, so that's the first limit done. Minus, this is potentially very easy to make a mistake here, isn't it? So that's why the first time I sort of did that to stop me from making that mistake. So minus, and then a minus 1 over k squared. So that's not the nicest thing in the world. So let's call this a plus. Anything else we should do here? Let's put the same denominator on it. So let's do a 2 top and bottom as well. So they're the same thing now. There's a 2 and there's a -1. So I think that's all going to turn into just 1 over 2k squared, isn't it? Okay, which gives me my final answer. Were we looking for? Yeah. So which gives me my final answer of 1 over 4k squared. Okay, and hence it is inversely proportional. So there we go. A couple of questions there that looked quite similar to one another. So what we really ended up doing there was different sort of types of integration by substitution.